Good morning and welcome to this EGEC Meet the Members webinar. And to start with, I give the floor to our President Miklos Antich for the welcome. Miklos, floor is yours.
Yes. Good morning, ladies and gentlemen. Good morning, the members of EGEC and the new members of EGEC. I'm very pleased to welcome you to this webinar, which is online again, where we are going to meet 10 new members, which very pleased me because we are exceeding now 200 members. It shows the great interest of the industry and the organizations towards EGEC, which represents your activities, which represents the voice of geothermal in Europe, and not only Europe, but in the world. Well, with this, I hope that we will have the chance this year sometimes to meet all of us and then meet personally and share information and networking. However, this event will give you an excellent opportunity to present your organization and give the opportunity to networking and meet other members. Please feel free to exchange through the platform, and I wish you an excellent meeting. Now I pass the floor to Philippe Dumas, who will host and moderate this meeting all over the time between now and 12:30. Thank you very much and have a nice meeting.
Thank you, Miklos, for this kind introduction. You are quite familiar, all of you, about this webinar, so we give a chance to indeed new members in a bit less than 10 minutes to present themselves and to give some information on what they are doing. You can see now the agenda of today. So we have indeed a series of members to present. As mentioned by Miklos, we have reached more than 12 members, more than 20 have joined last year. So indeed, it's a fast growing for us in the membership, which is good. And we will try as soon as possible to present you all these new members. I don't want to lose too much time. I will first give a floor to Sean Finlay, Director of Geoscience Ireland. Before that, let me remind you that if you want to interact, of course, you can raise your hand, but it will be hard to answer all questions. So the best tools is to use the chat or the Q&A online sessions. With that, it's my pleasure to give you the floor to you, Sean, to present Geoscience Ireland.
To have this opportunity to introduce ourselves and to acknowledge how pleased we are to be members of EGEC, which we find to be highly effective and cost efficient as well. Next slide, please. About Geoscience Ireland, we are a cluster of 33 companies and 2 research institutions. We provide design and construction services for renewable energy, minerals, water, and infrastructure. And of course, renewable energy covers geothermal energy as well. Turnover of our 35 members in 2022 was 1.2 billion, 400 million of which came from outside Ireland, and there are 4,500 employees in the 35 member companies. The skills include geotechnical and environmental engineering, surveying of all sorts, and of course drilling. Next, please. The main actors in Ireland are the Geological Survey, the Irish Centre for Research and Applied Geoscience, the Geological Survey of Northern Ireland, Geoscience Ireland itself. We have a Geothermal Association, and we have 2 companies, Causeway and Geoserve, whom you will come across, I hope, in the future. We have strong links, of course, as I mentioned, with EGEC, with Geoenergy Europe, and with the European Parliament. And we're very mindful of the success of EGEC in lobbying the European Parliament in having them adopt the experts' report, and also voting in favour of the Commission policy on geothermal energy. And we lobbied our own Irish MEPs in that process and received very strong cross-party support. Next, please. So our geothermal sector is very underdeveloped. That map from EGEC, I think, tells the story that there's no deep geothermal sources tapped in Ireland, and the reasons for in comparison to other countries in Europe, as you can see from that slide, The reasons for this are lack of awareness, lack of policy, and lack of data. Next, please. On the policy front, there have been quite a few developments since the beginning of this decade. The most recent of which you can see in bold there, there's been a policy statement published by the government last year, and draft legislation is promised this year. And the legislation will regulate will plan to regulate the sector as to who owns the energy and how is it to be extracted and how is it to be paid for. In addition, the Geological Survey of Ireland provides technical support to the government advisory group. And of course, Geological Survey Ireland is a member of Geoscience Ireland. Next, please. In terms of data, as was mentioned by several members of the European Parliament during recent debates, de-risking the subsurface is the key, and to do that, we need more data. For example, in the Netherlands, there's a subsurface database worth 10 billion and a lot of support measures. The main support measure in Ireland is the creation of a national, geothermal database. And that's under development by a company GeoServe, help from the Geological Survey and from the ICRAG. Next, please. I think this will probably be familiar to most people involved in looking at the subsurface. What we're trying to do is take all the data we have, seismic and well data, to help us with resource quantification, then to identify the specific play types, and move on then to heat production estimates and cost estimates to establish cost of supply, and of course to establish projects. So that national geothermal database is probably the key element of what we're involved in at the moment. Next, please. The other way of raising awareness and, of course, gathering data is a couple of demonstrators. Geological Survey drilled a 1 kilometre deep hole at Technological University, Dublin, last year and achieved a temperature of 38 degrees centigrade at 1 kilometre, which was surprising. That was unexpected. And some drilling last year as well in South Dublin to a kilometre established a temperature of 33 degrees. So the idea is to follow up these initial exploratory holes and try and determine some production statistics. There are a number of smaller projects in the university in Galway and in 2 of the other universities in Dublin involving heating of buildings and of swimming pools. Next, please. A larger demonstration project is taking place in Northern Ireland. Northern Ireland is in the strange position of being, in the European Union and not in the European Union, but it's part of the island of Ireland. We work closely with them. They have a 3 million sterling demonstrator project in Northern Ireland involving geophysics and drilling, one of which will be at the site of the Parliament in Belfast, Stormont. But a large part of that 3 million, I think 500,000 or 600,000, is being spent on education and awareness, which is significant. Next, please. Geoenergy Europe is a project that we worked on with COSME. It's completed now. It involved market study visits to Chile, Canada, Kenya, and Costa Rica. It was hampered by COVID restrictions, but we did manage to generate some interest and develop and gather a lot of information about those markets. And next slide, please. You can see on the next slide, you can see the participants. EGEC was a very important participant in that study, together with colleagues from France, Germany, Hungary, and Turkey. That kind of collaboration, I think, is crucial to the success of the sector. Next, please. So geothermal energy, as we keep telling our policymakers, is an unrealized remedy. I know that's EGEC's message as well. We have significant geothermal gradients and several demonstration projects in Ireland. We have regulatory and legislative changes underway, and our engineers and scientists can meet the challenges. My contacts are there, together with my colleague Joe Mongum, who was our lead for the Geoenergy Europe project. So that's it from us for the moment. Thank you very much.
Thank you, Sean, for this really interesting presentation of Ireland and indeed the recent development we have seen in developing geothermal in this country. Now we will fly from Ireland to Greece, and I will give the floor to Savvas Savvopoulos to present us Geothermal Target 2. Savvas, the floor is yours.
Thank you very much, and thank you for this opportunity to present ourselves in EGEC and to meet also other members. This is very important because we are going, we will start now the presentation. Let me try to share my screen. Can you see my screen?
I confirm, floor is yours.
Okay, perfect. Thank you. Together with Mr. Evangelos Spyridonos, we are members of Geothermal Target 2, SA. We are based here in Athens, in Greece. And I will make a small introduction of the company. Geothermal Target 2 is a joint venture of SPV by Elector. Elector is part of Lactor Group. And PPCR, which is the public power company of Greece Renewables, with 51% and 49% respectively. The main purpose of the company, of the SPV of Geothermal Target 2, is the financing, engineering, installation, construction, and operation of geothermal power plants for the exploitation of the geothermal potential of the following geothermal locations in Greece. It's the island of Lesbos, the first geothermal location, island of Nisyros, the complex of islands of Milos, mainly Milos, Kimolos, and Poliegos, and Methana Peninsula. The confirmed, I'll go to the next slide. The second target is the financing of the geothermal power plants, includes engineering, procurement, construction, of course, supervision, installation, operation and maintenance, and of course the exploitation works for the production of electrical work for the power plants. And the third target is the exploitation of the ZeroGeo product for direct thermal use, either for production of potable or irrigation water from seawater, since these islands, most of these islands have limited sources of fresh water. And the second is thermal energy for district heating, which is limited as a use in these islands due to the weather. But there are potential uses for agricultural and industrial uses. The last one is exploitation of geothermal byproducts as minerals, which are included in the geothermal fluids. Evangelos would like you to add any further details on what I have already added?
Not very much. Like I said, the main purpose is, of course, the production of electrical power, and also the uses for thermal uses for industry and also for tourism on these islands, which is quite a growing market. And the future is the use of extraction of minerals, but this has not been explored yet. I comment a little about the geological situation in Greece. The geothermal potential of Greece is connected to the development of volcanism from the late. Go to the next slide, please.
Yes. Is the South Aegean
we can see the locations. So
these are the four locations which I was referring to the presentation. Methana is the left one, where you can see near Athens. Milos is the next one on the south side. Nisyros, it's near the coast of Turkey, near Rhodos. And Lesbos, which is on the north side of the Aegean, you can see the red.
Yes, so you can see here, all these locations are connected to the development of volcanism. So for the northern part, for Lesbos and even the northern Greece, the volcanism is of late Eocene age. And as we go to the south, it develops to the modern active volcanic arc, where Methana Milos and Nisyros are located. The Nisyros and Methana are actually active volcanoes. Milos is not an active volcano, but the magma is estimated to be at about 6 kilometers deep. So we're going to go to the next. I think this is enough with development. So, and here you can see where our projects are located. We'll shoot again. And all these red dots are the other geothermal areas in Greece, which are right now under exploration from the Greek Geological Survey. Okay.
I will pass these details, if you agree, Evangelos. We'll go to the main,
Yes.
just to present the locations of the power plant
Yes.
developments.
Okay, so this, for the Milos geothermal field, development started about 40 years ago, but it had to stop due to a very strong local opposition from the local population. But there have been drilled 5 deep wells with temperatures up to 323 degrees.
It's a very high enthalpy geothermal field in Milos. The temperature confirmed, it's a confirmed also field, we have to mention that. On the depth of 1.3 kilometers, the temperature is 320 degrees.
Okay, we can go to the next. This is the some chemical characteristics of the fluid. Okay, we can go to the next. All these have been published, so you can find it also in the literature. For Nisyros, the temperature is even higher, but of course it's quite difficult fluid because it's an active volcano. There's also a high content of non-compressible gases in these geothermal fluids. Go to the next.
Going to the next one, this is the interconnection of Nisyros with the other islands.
Okay. This is the location of the drill holes, all drill holes on Nisyros, and again the characteristics of the fluid. Okay, we can go to Lesbos.
Lesbos. Yes.
Lesbos, this is in the northern part of the Aegean Sea. Geothermal potential there is due to the volcanism of Miocene age. It's not so hot as the active volcanic arc, but we have more than 100 degrees at depths about 300 meters. And the geothermometers indicate that we can reach a reservoir at about 160 degrees at, we hope at 2.5 to 3 kilometers deep.
This is the current situation, the next steps for Lesbos. Since there is exploration survey, which is...
This exploration is ongoing. We're going to publish a tender for a seismic survey on Lesbos the next month. And we can go to the next slide. These are the areas of interest in Lesbos. We are now focusing on this northern area. Okay. And finally, the Methana Peninsula is a small peninsula south of Athens in the Salonic Gulf. It is also an active volcano. It's part of the active volcanic arc of the Aegean. We have very strong indication for good geothermal resource at depths about 1,500 meters to 2,000 meters, but there has been no deep drill hole yet. Also, we have some implications there because the whole area is an archaeological site, so we have to coordinate our exploration and drilling with the archaeological authorities. Savvas, you can continue.
Yes. So the plan for the next period is the drilling, exploration, production, drilling of geothermal wells, to commence in 2024. And then after the successful drilling of the wells, to finance and develop the geothermal power plant in Milos. The license will be, it's up to now, it's for 5 megawatts, but the target is to go and grow further this power production. The challenges, just to summarize a little bit, the challenges for Greece, because it's something very new and the local community is still not favorite of these technologies, and they're afraid of emissions. Our commitment is to have 100% reinjection in all the power plants developed in Greece. So for Milos, the plan is to start drilling on 2024 and to have a production and reinjection wells by 2025 for the development of the geothermal power plant. The next location is Lesvos for a power plant of 8 megawatts for electric production, and for Methana, 5 megawatt electric production. The immediate plan for Lesvos and Methana is to complete and to have location for the geothermal drilling wells the next period within 2024, and to start drilling on 2025. Just to summarize the challenges, the proven geothermal fields are in Milos and Nisyros up to now, where there have been geothermal wells drilled in the past. On Lesvos, there are strong indications for high temperature reservoirs, as we mentioned earlier, 160 degrees. And the plan is to start drilling within 2025. On Methana, apart from the completion of an indication of the location of the drilling of the geothermal wells, is to complete and to have the study for the locations to prove there is a geothermal, not to prove with the geothermal wells, but to have an indication of a good geothermal field in Methana, which is not proven. Milos and Nisyros, in both two locations where we have high enthalpy, there is a lack of social acceptance of the projects, and we are working on this front with both locations, and mainly in Milos. And the energy demand in these islands, which is very low, especially during the winter months, where the power consumption is very low. So we will depend on the interconnection of the islands with the mainland, so the production of power can go above what we have mentioned already for 5 megawatt, and to grow further. The other big challenges are related with the usage of energy, which we mentioned earlier in the presentation, is that has to do with the use of thermal energy. Due to the season, due to the climate of these locations, there's no purpose of district heating or other uses for thermal heating. The only potential use in Milos would be to use it in industries, which are also limited on the island due to the tourist the main column of the main pillar of Milos is tourism. So these are the big challenges in these islands. So where we have the geothermal field, it's not easy to use the thermal energy. The only energy we can use is electric power. Plus, we need to have 100% reduction because almost all of the locations are environmental sensitive.
Okay.
Maybe the conclusion, no?
Go to these details.
This is also this. Savvas already mentioned this. So the main problems are the lack of social acceptance. We're working on this, and of course the problem of the interconnection, because the demand on Milos and Nisyros is, especially during the winter, very low. And the interconnection is planned, so we hope that by 2025 the islands will be interconnected to the mainland, so we can have a production independent from the local demand. And also a big challenge is to convince the locals that they can use thermal energy or also for tourism, because tourism is the main economic activity on these islands. So I think this is all said for these projects, and we are working on developing them after almost 40 years of stop of geothermal in Greece. Now, in the last 3 years, we started again to develop the projects, and we also have the support of the authorities at least from the Ministry of Energy. We have also a new modern legislation which try to do things better and account for the experience for the old legislation, the problems we have encountered. So the new legislation is quite simpler and it's easier to implement the projects.
Thank you very much, Savvas and Evangelos.
I trust, just to complete the presentation, is that we are looking with EGEC to cooperate on the communication policy and for the convincing of the local communities to accept the use of geothermal energy and the production of electric power. And we would like, if there are information on this regard, to share information with us. And to participate in seminars on this regard, how we can develop communication tools and to use these communication tools with the local communities. This is one very challenging point, because the technical issues like the use of thermal energy, we can use it for production of fresh water, as we said, potable or irrigation water. Or for even to create thermal spas with the local communities or developers of resorts in the area. These are solutions we can find, but the big issue to develop and to start developing the geothermal power plants is the acceptance of the local communities. And this is what I would like to complete.
Thank you, Savvas, for this complementary information. Indeed, it's a topic as EGEC we work on replicating best practices to deal with environmental concerns. We are planning several events, meetings on this topic, so you will all be aware of it. Thank you. So now from Greece, we fly to Ukraine and we give a floor to Taras Popadynets to present us Geothermal Ukraine.
Okay, thank you very much for being able to present our activities within the EGEC community. Thank you, Mr. Dumas, for letting us enter this valuable society. So let me present our latest activities and briefly about our organization. So we are the non-profit R&D organization founded in April 2022 with a mission to prompt development of R&D activities for reveal the geothermal energy potential of Ukraine. And we are foster of the global energy transformation, where the geothermal energy will play the pivotal role for the energy transition, for the net zero target, and for the low carbon future, for the new generation, of course. So here is the website you might visit, and we will be able to present the new one in the beginning of the February this year. Briefly about the area of our activities, so we might define the several of them, and the key activities are the scientific and the technical research for the geothermal potential of Ukraine, and the R&D projects for the further development of the geothermal projects, the implementation, the fit for purposes and efficient technologies for the process of exploration and production of geothermal energy resources. The feasibility study for the repurposing of existing oil and gas wells for geothermal energy production, as well as using the subsurface database from those wells. The educational activities to promoting geothermal energy potential in Ukraine, and revision the revision and improvements the proposals application into the state regulation for the national authorities to clarify it for the geothermal project development. The last but not least is the cooperation with the state and local authorities, the scientific institutions and universities, relevant commercial, intergovernmental, and international organizations. And about the projects ongoing and past projects, the few words to highlight what is done in Ukraine and what is ongoing. About the recent projects for repurposing oil well in Western Ukraine under the NEFCO fund, I have to highlight that the feasibility study was done a year ago. Our current project, which we are as an organization involved with the partnership of Vertis and ESOR under the Sustainable Development Goals Partnership Fund, is the geothermal direct use potential opportunities for the geothermal resources in western part of Ukraine. Within this grant project, we are building the relevant database from the currently being drilled and plugged oil and gas wells, as well as geothermal ones, for making the holistical source of data, for being able to select the best leads, the best potential areas where the further detailed study will be done for the further commercial application projects. So we also are very much proactively applying in the consortium basis within the Horizon Europe projects related to geothermal energy. And just wanted to highlight that being able to collaborate within the EGEC community, it's much easier to find new partnership and new consortium within the further application on such a horizon projects. So we already applied for several other programs like Innovate Ukraine program within UK and Ukraine, the RVO within the Netherlands and Ukraine, the Energy Cities projects for the smart city, where the geothermal and geoenergy as a whole might play a key role. And the last but not least, the scientific and educational activities for the information campaigns for the so-called social related aspects for the social license for within the community. So the trainings, public awareness initiatives, conferences, workshops, webinars, publications have been participated in. Just to highlight some key points there, we are very much proactive within the elaboration, the opportunity for making some training activities in Ukraine with our current partners and the members of EGEC Black River. With another one is the participation in the Petroleum Engineering Summer School, where I was honored to meet the Mr. Dumas the previous year, and our members also presented the opportunity of geothermal potential in Madrid within the APG International Conference. Among that, I also been able to visit the geothermal workshop in the Utrecht University, which the information about that was provided by EGEC newsletter. So, to summarize the outlook of cooperation within our organization, we wanted to highlight the three main options for different communities. For the business and industry, we provided the access for the large network of geothermal companies and experts. So we support the business for exchange knowledge and information within the working groups. We're providing the access for relevant information, customizing industry standards and protocols, innovations and investment opportunities. So we also support this marketing platform where the projects might be presented. The technical guidelines and best practices with the successful project implementation around European area as well as globally. Also, we struggle to provide the access to the international funding opportunities for geothermal project development. For the scientific community, we propose the support for the joint research initiatives enabling scientific institutions to access the industry insights and the best practices. So we collaborate within the educational program tailoring by our members and partners within the scientific related organization. And access that they participate in various knowledge and networks meetings. So for the regulation and authorities, partners, we are struggling to update and making proactively proposals within the best practices of legislation and regulation environment, which might be applied in Ukraine based on the European and global standards and procedures. So we, as of the collaboration of making changes to geothermal energy policies and regulations, so we also struggling and focusing very much on the collaboration with the local communities. So the social license, making the connection between the social and the business-related stakeholders, our key role within the project activities. And being succinct in this presentation, I would like to thank you for the attention, and we're expecting from the EGEC community the further collaboration and transfer this knowledge and best practices from both technical related aspects as well as social related communities and collaboration, let's say, workflow for being success into the commercial application of the geothermal project. Thank you very much. And yeah, this is all from my side.
Thank you, Taras. Indeed, quite interesting to see that in Ukraine there will be probably a lot of potential development for geothermal, and we should all support you in this development. Thank you, Taras. Now from Ukraine, we are flying to Germany, and I will give the floor to Ulrich Hahne from Herrenknecht. In the meantime, I'll ask maybe Evangelos and Savvas, please look at in the Q&A, there are several questions about Ukraine, so if you can write your answers to them, it will be welcome. Ulrich, the floor is yours.
Yeah, okay, appreciate it. Can you see the screen? Just double checking. So
we can see it, not in full screen, but
okay,
we can see it.
Okay, well, this should yeah, go ahead. So thanks for the opportunity first of all, and welcome everyone. Herrenknecht or Herrenknecht Vertical, we are a manufacturer of drilling rigs and drilling equipment in general. What you see on the next slides, the picture in front of you shows one of our rigs drilling in the southern part of Germany, in the area around Munich for geothermal wells. There are currently rigs from us drilling in this area right now. So an area we are developing in Germany, and where we as a company providing rig and drilling solutions for. The Herrenknecht Group, we are known in the tunneling business. So we build drilling equipment to drill tunnels. That's where the majority of the revenue of the company is coming from. We have about 5,000 employees and create 1.2, 1.3 billion euros in sales. And the company was founded some 40 years ago, so it's a relatively young company. And as we are growing, we looked into other areas to provide equipment to the industry. And already in 2005, founded Herrenknecht Vertical to supply drilling rigs and drilling equipment to the market. In regards to segments, we as a group working on, so you see us or our equipment being used in water wells to supply sewage infrastructure, water supply, desalination. That's where some of our smaller machines are used. In energy a lot. That's the main focus is on geothermal energy, but we also drill offshore piles for offshore wind parks, for example. In minerals, we have a division that deals with mining, that is looking into mining, and the large majority of our revenue is generated building road and railway and metro systems. So as a nutshell, as a typical, you look at some how our equipment is looking like, is of course very difficult to remember or to see this. But what you see here in the first row, these are tunneling machines. That's not too different than drilling an oil and gas well, but we're not drilling 8.5-inch as in geothermal, for example, but 8.5-inch meter or 10 meter or 12 meter in diameter. So these are large tunneling machines. You see here so-called HDD rigs. This is for crossing rivers, where this equipment is often used. And you see here at the bottom, these are different drilling rigs we use in geothermal application. As I touched on, we are a large drilling company. So in this picture, you see a project that is ongoing today. Is the extension of the Paris Metro, and in this application or in this project, we're using 21 of these large tunneling machines with 10 meter in diameter to construct a metro system, or to extend the Paris metro system for the Olympics. So wherever new metro systems are, as an example, are built, or large infrastructure projects, we usually involved and be providing equipment. And that's being said, we are quite that's common for us to stay in projects, to have projects that run 3 or 4 or 5 years, and to build subsidiaries where we are operating is very common on us. I could show you, this is just an example, the same slide on London, or London Birmingham, where we built a new high-speed train, or other infrastructure or energy projects globally. And the division where I'm responsible for is dealing with drilling rigs, or building drilling rigs. This was founded in 2005 already, as we felt in 2005 was that time where Central Europe and Germany in particular is developing geothermal application. Now that hasn't happened at the time, but we used the years to build further rigs and rig designs, and today our rigs are known to be being able to operate very quiet. So we use our rigs to drill in downtown Munich, for example. We're just building a new rig that you're welcome to visit, and will be ready this summer to drill in France, in Paris, downtown, and that shows, in our opinion, how the industry further developed, and what the focus is today, to provide heat in cities, and that's what we are building equipment for. Our rigs are usually highly automated with a high degree of focus on safety, so you need less personnel to operate those rigs. They're usually operated from the grid. Luckily, most of the geothermal work we do today is that the rig is powered from the grid. I mean, not using diesel or gas engines to provide power to the drilling rig. But we developed this further, and for example, have storage systems today and energy saving systems when you have moving parts like this pipe handler here as an example, and every time you move this system, you can store energy and reuse it while operating your equipment. So that's another focus we have, and where we see further developments as we move forward. And the large point I wanted to touch on is like a drilling simulator. We just investing tool that allows to, beside not only providing rigs, but to perform training at our facilities. As in some areas, we reckon there is a lack of personnel operating drilling rigs and drilling equipment. With this drilling simulator, we can not only drill wells on paper, but we can also train workforce in order to work safe and efficient, and that's what we gonna do going forward. And that was, I hope, very quick in a nutshell on what we are doing.
Thank you, Ulrich. No, really precise presentation, and yeah, quite known companies anyway in this sector, but it was quite interesting anyway. And I invite all the participants to ask you a question they may have in the Q&A session. With that, now I'm giving the floor to Antoine Jeannou from Pluton DG in France. Antoine?
I'm Antoine Jeannou, the founder of Pluton DG and the designer of the geothermal energy buffer innovation, grid-scale energy storage solution that offer performance comparable to that of hydroelectric systems. I'm a geologist, over 30 years of experience is monitoring, preparing complex oil and gas operation. And I finished my oil and gas career as a project quality assurance assessor. Pluton DG is a small structure focused on the development of our patented energy management solution. It's a tool based on geothermal energy. In few words, I will try to introduce you to the geothermal energy buffer, the GEB innovation. First, it's a deep, I don't know if you will see the...
Yes, we can see the fluid, yes.
Yeah, yeah, but laser. So first is a deep geological storage facility for LPG. The liquid gas is an organic fluid that allows its phase change to be turbined at surface. It's then re-injected and it is recharged with energy using the geothermal water. When energy is not being generated by the turbine. So it's functioning like a pump storage hydro. It's production when the grid is demanding, and storage when there are no power demand. The geothermal water is superheated, and in this process we store variable renewable energy and any other thermal production to recharge the system. This system is a responsive storage solution. That means we get the energy we store. It was calculated like that. This slideshow is the results of our studied estimation of GEB's energy balance as a percentage. So we start from the enthalpy of the fluid at the reservoir condition, which is 100%. And we had this cold and electricity production, cold without hot exhaust. Any thermal energy, hot thermal energy, we like it because we use it for the recharge. So with the turbine, we could work with the data of the turbine we could work with. We reach 20% yield from starting from the 100% of original enthalpy. The recharge is so you see mainly overheated water, and we overheat using hot heat pump, high temperature heat pump, and we in our calculation, we are modeling, we success to reach this level of this efficiency, 99.4%. So 0.6% remain to be recharged by the geothermal energy. So we got this number, an energy production of 3.7 megawatt for 6 hours because the it's the usual number given by the hydroelectric production in France is 4 to 5 hour generation. So we calculate with 6 hours and with 18 hour time for the recharge. This is an attempt to compare with conventional batteries. The energy used for the storage are the pumps and the heat pump, and we have this production. So we generally a chemical battery has a performance of 80 to 90. So if we improve the production, we could reach the performance of chemical batteries. Before comparing jet performance with other geothermal solution, let's review the main indicators characterizing the geothermal energy. First, it's flow rate. The energy is just a multiple of the flow rate, and the mass flow and the enthalpy of the heat transfer fluid. And second, it's the time duration of the exploitation. It's the lifespan of the system, and we have because we are working in a sedimentary basin or not in a some specific tectonic setting, volcanic or like volcanic setting. We are dealing with a very weak geothermal heat flux. So we have in fact what we are doing in a geothermal operation, we are destocking a thermal energy stock. So I used I based this slide on some Fervo communication, and to see the flow, different flow of different geothermal solutions. But first, the HDR, they are shallow volcanic setting. They were performed in shallow volcanic setting with fracturation. Historically, they are the oldest geothermal specific operation. Then after the EGS, you have here more or less the main flow performance. But we see that Fervo are really they success to have a breakthrough. But we have to tell that Fervo are fracking shallower, and it's kind of a volcanic sediment is not fractured sediment, and they success to have using the latest fracking technique. They success to have this kind of flow rate for the heat carrier, the fluid. EVORS, it's difficult to get the data. They are using a thermosiphon circulation. Orally, we could have this information is probably below 20 liters per second. And for Geb, one well gives us 50 kilo per second. We are limited by the reinjection. If not, gas production naturally could be much more. But at the feed scale, if we upscale at the feed scale by storing, for example, an LPG boat of 80,000 tons, we can reach more than 1,000 kilo per second, which gives us probably power capacity of more than 100 megawatt. But here, for the duration of the exploitation is indefinite, because we are dealing with a closed system, and the LPG store in this geological storage and is stored forever. So well, but I hope I have interested you with this innovation. This innovation is patented, and I'm ready to study any form of collaboration, because I'm proposing a tool, a solution, not a company project like the conventional startup offer so we can see in the market. Thank you for your attention.
Thank you, Antoine. Indeed, it was quite clear to plant this dissolved buffer, what we have already discussed, notably in the ETIP.
Okay.
Thank you, Antoine. And now we will give the floor to Michal Masek from PV Geoenergy, and the floor is yours to plant your project.
Thank you, Philippe. Hello, everyone. Can you hear me? Can you see the presentation?
Everything is perfect. Floor is yours.
Okay. My name is Michal Masek. I am a project manager with the company PW Energy. PW Energy is similarly, as our colleagues in Greece, a SPV joint venture between PW Energy, which is already a EGEC member since 2020, and SSE Holding, which is the Stredoslovenska Energetika Holding. It's the major Slovak, Middle Slovakian power utility. This company is focused on developing one geothermal concession in Slovakia. It's in the central Slovakian region, in Žiar. So here you can see the concession, which extends to about 60 square kilometers. We have been developing this concession since 2018 with PW Energy, now with PW Geoenergy. We have performed all the required geological surveys on the surface. We have retrieved a large amount of archival data from the Slovak National Geological Institute. We have done our own seismic survey in 2019, so basically everything that could be done on the surface in this region has been performed. We have finally received the final decision from the environmental impact assessment process. Took us only 1,000 days. We have identified and purchased the land plot for developing the first geothermal power plant in Slovakia. Right now, a public procurement is running for drilling the first 2 wells in this concession. The registration is open. If you are interested, just send me an email after the presentation. I can give you more information. Just very briefly about Slovakia. Slovakia is relatively well positioned in terms of geothermal potential. Related to mainland Europe, we have relatively high geothermal gradients. However, there are only maybe 3 regions in Slovakia that can be utilized for developing geothermal power plants. There is a lot of potential for heating, but for power production, we are a little limited. Based on our relatively recent hydrogeological assessment of the reservoir, which is actually a Mesozoic carbonate dolomite reservoir, the expected heat potential of the whole region is approximately 440 megawatts thermal. This heat energy can be or is expected to be used for power production, mainly using binary cycles. You will see the parameters later. There are also options for utilizing the heat directly or the waste heat for many applications, as you are well aware. One interesting fact about the region is that Žiar nad Hronom is a largely industrially developed region. There are a lot of major smelters in this area who are actually transferring from gas to electricity, which makes this project very interesting for them in terms of PPAs and power purchases of electricity from this power plant. The ultimate goal of PW Energy is to develop 3 power plants based on ORC technology within this area that could potentially be in a range of approximately 20 megawatts of electric installed capacity. A little about the anticipated parameters of this project. So, as mentioned, we are looking into developing 3 power plants with a collective capacity of approximately 20 megawatts electric that would be able to generate at least 140 gigawatt hours of electricity per year. Few information about the reservoir. The top of the aquifer is located at 3,100 meters with a temperature of 124 degrees Celsius. It extends about 1 kilometer deeper into 4,100 meters, where the expected bottom hole temperature is around 164 degrees Celsius.
Michel, 1 more minute?
Yes. So briefly, we are looking at capacities that can supply approximately 2.1 megawatts of electric per well. Each of the power plants is going to supply by 3 production wells, or relatively 3 doublets. The first phase, the first power plant that is already permitted and we have the land for, is looking to have 6.5 megawatts electric in the investment of about 80 million euros. It's going to be built in 2 stages. I'm sure Philippe and his colleagues will share the presentations. You can look at this in more details. Next stage, after the first wells are drilled and the reservoir is confirmed and the parameters, we are going to go for another 2 power plants. Land for one of the second power plant is already purchased and EA is in preparation. Of course, last but not least, there is a lot of benefit related to the reduction of emissions. There is a coal power plant in central Slovakia that can be partially substituted by power from the geothermal power plant. We are basically cooperating also with the Slovak state because that is an investor in SSE Holding. Thank you for your attention. If you have any questions, please send me an email. You have my contact details here and you will have the presentation later on available.
Indeed, for sure, we will share the slides. Thank you, Michal, for your presentation. Quite interesting to see what is happening in Slovakia.
Okay. Thank you, Philippe, and thank you to the organizer. We are very happy to be part of this EGEC partnership, and I thank the organizers for the opportunity of introducing University of Trieste. I guess there are many other Italian members of the in the EGEC community. We are a university, so an educational and research institution, and actually part of a lively network, quite lively network of scientific institutions based in Trieste. This is a short overview of the constellation of scientific institutions, and the ones that are mainly involved in geothermal energy together with our university are the International Center for Theoretical Physics and the National Institute of Oceanography and Experimental Geophysics, with which we collaborate both in the field, in the general field of earth sciences and in the specific field of geothermal energy. By the way, I recall that we had the pleasure to interact with President Antix in past years in the organization of a school, an international school for geothermal exploration that had a number of, of different, editions in the years. So as far as the earth science community and its involvement in the geothermal energy field, we are a large group. Our department is named Mathematics, Informatics, and Earth Sciences. And actually, the components of the mathematical and data science part were merged also because the involvement and the application of mathematical techniques in the field of earth sciences is it has been always important, but it will be more and more in the future with the opening of large computational opportunities for solving complex problems and processing large data sets. So a short overview of the groups that are involved in geothermal research and education. We have a group of structural geology that deals mainly with the reconstruction of the subsurface models, starting from the surface and going actually in depth at crustal depths and at basin scales. I am the responsible for a geophysical exploration group that has a number of the topics related to geothermal energy that go from the numerical simulation and application of machine learning for, say, the simulation of mass and heat transfer in the geothermal reservoirs. But our, say, our main activity is the application and the development of the methodological developments in the field of numerical modeling and inversion with reference to mainly seismic methods, seismic reflection methods, for the assessment of resources and characterization and the monitoring of the reservoirs. This comes from our expertise that is based on, say, more than, say, 50 years experience in the field of first hydrocarbon exploration and then basin studies. And in more recent years, we dealt with problems related to the study of geothermal reservoirs. Another group is working on the geodynamic part and the assessment of the potential based on large-scale studies and on potential methods from the geophysical point of view to understand the potential of large provinces. And this group is working on a number of projects in Italy and abroad. And eventually, part of the exploration group is always dealing with the reconstruction of subsurface model through the integration of several sources of information based mainly on seismic imaging, but collecting also and integrating in the model borehole, geological surface, and other geophysical techniques information. As a research and education institution, we are mainly involved in research, the methodological development, and training at all of the levels in the university. And so we are really looking for cooperations in the EGEC communities, because for our young people, it's also important to have the opportunity to test their methodologies on real cases. We have the opportunity, and we have had in the years the opportunities of working on real data. But for a scientific institution, this is not so easy and not so frequent. So we will welcome any opportunity that will come from the EGEC community to cooperate and to have the pleasure to work on real cases and real data with our techniques. Eventually, I would just mention the fact that I am the coordinator, and we have here in Trieste a master course in geophysics and geodata, where geothermal energy occupies a part of the training program. And this course is offered in cooperation with the departments of physics and engineering of our university, and with the institutions that I mentioned, that is the International Center for Theoretical Physics and the National Institute for Oceanography and Experimental Geophysics. So in case there are interested young people in training programs, also short training programs, we are very open to cooperation. And eventually I conclude with an image of our beautiful town. Thank you.
Thank you, Michele. Really concise, precise presentation. Thank you. Indeed, quite interesting to see that indeed in geothermal we need, of course, to collaborate with university to also develop further research, innovation, and project. Thank you, Michele. So now I move on and give the floor to John Ashbridge from ZeroGeo Gmbh. John, the floor is yours.
Thank you, Philippe. I'll share my screen. Great. Well, thank you. Well, good afternoon. Thank you to EGEC for this opportunity to introduce how ZeroGeo is deploying our next generation hot dry rock technologies to store and generate energy from rocks. We are a we're a Swiss-based company founded in late 2021 by former oil and gas executives. Team ZeroGeo comprises commercial, legal, project development, and technical experts committed to deploying their skills in the energy transition. We are building reliable, low-carbon energy storage and power generation assets with next-generation hot dry rock technologies. We have 2 operated projects, one in Switzerland and one in Germany. We are technology agnostic and are transitioning and deploying the best technologies from oil and gas into European green energy projects. TerraThermo is our joint venture with Sage Geosystems, which allows us to deploy their hot dry rock geostorage and geopower technologies across Europe. We're also collaborating with Eden Geopower to deploy its electrical reservoir stimulation technology in Europe. Project Thermo in Lower Saxony has been underway since late 2022, when in partnership with OMV, we applied for 2 geothermal permits and completed a 5,000 square kilometer airborne full tensor gravity and magnetic survey. This was the first time this technology has been used to explore for geothermal resources in Europe, and in 2024 we will see further FTG surveys in Europe for geothermal exploration. Project Teeth is our baseload storage and power generation project in Switzerland. We are working with a large Swiss power generator and an industrial off-taker seeking to decarbonize its power and heat supply. Again, we are focused on deploying hot dry rock technologies where we know the geology and heat flow is suitable. TerraThermo is our joint venture with Sage Geosystems. We are deploying their hot dry rock technologies to provide storage and power generation solutions to a wide range of energy industries, from repurposing oil and gas wells to co-location of geostorage with solar and wind farms, through to providing hydrothermal and thermal operators the opportunity to harness new subsurface heat resources. For 2024, we are excited to be collaborating with Eden Geopower to deploy their innovative and groundbreaking electrical reservoir stimulation technology in Europe. It provides a sustainable and environmentally friendly alternative to traditional hydraulic fracturing approaches that are essential to increase fluid flow between boreholes. And it increases permeability in geothermal and geologic hydrogen reservoirs to maximize heat extraction and economic value. Given the current hydraulic fracturing restrictions in Europe, most European countries, we see huge opportunity for this technology. Also in 2024, we see increasing demand for our advisory services, utilizing our proprietary HDR Finder product that allows us to explore for hot dry rock resources and the technologies we are transitioning from oil and gas. We are advising national and state governments, municipal authorities, and private companies on how to decarbonize their power generation supply and consumption. Just a what-if scenario here. Switzerland's annual electricity consumption of 57 terawatt hours could be supplied with 240 geopower plants on 4-hectare sites. That would take 2,400 boreholes. It's a lot of drilling, but not compared to the 60,000 oil and gas wells that are drilled in the world every year. And all of these geopower plants would require an area of less than 10 square kilometers, which is the same area as Lac de la Grille it's a lake in Switzerland. So in closing, our company is at the forefront of the energy transition in Europe. We are confident that Europe has the right geology to deploy hot dry rock technologies, which will greatly enhance Europe's energy security and supply. Please check out our website and follow our LinkedIn profile for further information on our company and its projects. Thank you for your interest.
Thank you, John, for this quite interesting presentation indeed on what you're developing in Germany, in Switzerland, and as we are seeing also in the UK. Maybe there would be also some questions for you, John. I first thanks all the presenters for answering online and the questions. So feel free to ask a question to John about the technology development he's doing. Now we are going to the last presentation, but not the least, and I'm giving the floor to Damien Blanc, from INGEN Innovation Geoscience. Damien?
So thank you for the opportunity to give us the time to present our company. So INGEN Group is a French company dedicated to geosciences. It includes two different companies. So INGEN Innovation Geosciences, which is an engineering study company dedicated to geological expertise. We have as well our rock laboratory for every kind of rock analysis. And on the other hand, we have INGEN Logging dedicated to mud logging operation for deep geothermal wells for on-site operation for the geological monitoring of the drilling parameters. Our main clients, as you can see, we all come from an oil and gas background, but we are now transitioning to geothermal, which represents now more than 40% of our turnover. So we are now playing with big companies in France like Lithium de France and Compagnie Française de Géothermie. And this is the kind of innovation that we are able to develop. This is the analysis tools, so we can develop and manufacture for our clients or for our own needs. We are able to deal with software, AI as well, and also really specific projects for geoscience analysis. We are able to provide a complete integrated upstream studies for the exploration projects and drilling projects everywhere in the world, so such as stratigraphy analysis, sedimentology, basin studies, but as well reservoir engineering as well for the characterization of the reservoir and the pay zones. So we do that in France and as well in Europe. We have our laboratory, Rocks Labs, which is an important part of our geoscience portfolio. We are able to provide all the kind of analysis needed to identify the rocks and the geochemicals properties, so from zinc section, manufacturing, petrography, mineralogy, granulometry, and geochemistry. We have a fleet of the state-of-the-art equipment to provide the fast analysis. So most of those equipment can be mobilized at site as well if needed. And this is the kind of technology that we can as well develop specific programs and specific identification for exploration projects. To be able to de-risk as well for the shallow geothermal project. We haven't heard much about the shallow geothermal project, but we have developed a specific de-risking solution with specific ground penetrating radars. We are able to see up to 120 meters to detect the different cavities, to be able to avoid losing the kind of probes and drilling strings into the cavities, which happens a lot of time on shallow geothermal projects. So this is the kind of services we are able to provide, even the materials and the training as well for the operators if needed. Now I switch to the second company, which is INGEN Logging. INGEN Logging is a new company dedicated to the mud logging at site to provide accurate geological monitoring while drilling for deep geothermal projects. We have worked on many geothermal projects in France, in the basin of Paris, and in the south of France as well. We have a strong experience. All the cabins, mud logging cabins, are developed and made in France by our development teams. And basically, it's a fully integrated mobile laboratory, which includes all the different kind of analysis you can imagine to be able to do the live monitoring of the drilling parameters. We have developed our own software as well for the clients to be able to follow up the different drilling parameters while drilling. So it's sent through the internet to be able to take important decisions. And we provide so the equipment, the different sensors on the rig, and all the different kind of analysis on site required by the clients. And of course, the well site geologists, which are here to do the geological monitoring and be able to realize the good operation and the remote follow-up as well for the drilling operations. So I that's it for us. So thank you very much for your time. You have all the contacts here. If you need any question, if you have any question, feel free to ask. And I hope I have been
Perfect. Yes, indeed, Damien. Quite interesting. Also, yeah, the tools you develop both for shallow. Indeed, it's quite rare to see this development in shallow of new innovation, new technologies, and also for deep indeed. If we look at, you can see soon we will present the market report, and everybody could see from the market report what are the development for both shallow geothermal heat pumps and larger systems. With that, I think it's time to conclude this webinar. I thank you, all the presenters, really interesting, and thank you for being quite concise in your presentation. We respect the time frame because we are planning to close at 12:30. It's nearly 12:30. Thank you also for the presenters to have answered the question from the audience in the Q&A sessions. And of course, thank you to the participants to this webinar. There were 60 people from the start to the end. So indeed, it was quite interesting for people because they all remain for the 1 hour and a half session. Indeed, time to conclude this webinar. It's recorded. Presentation will be available. And soon we will announce new EGEC webinars in February and March. And with that, I wish you a good end of the day. Bye-bye.